Hello and welcome to Dove Biology APES Lessons to Go. In this video we'll be exploring energy efficiency. Before we can examine energy efficiency, let's talk a little bit about how energy use has changed over the course of human history. Our earliest energy sources were that of biomass, like wood, which would be used to create fire to cook our food, to light or heat our homes. With the onset of the Industrial Revolution, that biomass fuel was then utilized to power our steam engines in order to move the factories of the Industrial Revolution. Now, wood fuel is a finite resource if not allowed time to replenish, and so we depleted a lot of our forest and we had to come up with an alternative energy source. And fortunately, we were able to utilize coal in place to continue that industrial revolution. In 1885, Carl Benz invented the internal combustion engine, and coal would not work well to power such a device, and so we needed a liquid fuel. And so we saw the use of petroleum increase at this time, and it continues to be used heavily today. In 1950, we had the onset of the nuclear age, as nuclear fission was brought on board to be able to be used as an energy source. And we thought that perhaps this would be an energy panacea, a one-size-fits-all answer to our problems. But unfortunately, as a result of the waste that it produces, as well as the potential dangers associated with the facilities themselves, they really have not become that one-size-fits-all energy answer that we were looking for. Now, almost 3/4 of the world's commercial energy comes from non-renewable fossil fuels, where the rest will actually come from non-renewable nuclear fuel and then other renewable resources. Energy use in the United States actually varies quite a bit by region and what's available to that region. For example, New England and Mid-Atlantic states rely pretty heavily on nuclear fuel, whereas the South Atlantic, South Central, and most of the Central and Mountain states are going to rely more heavily on coal because they have coal resources where they are. If we head out to the Pacific states, which have access to big rivers, hydroelectricity, and also solar power, they're going to be able then to rely on renewables. Alaska, due to its isolation, but huge resources of oil and gas, that's going to be their primary energy source. Now, unfortunately, when it comes to energy use, there's significant energy waste. In fact, 84% of all commercial energy used in the United States is wasted. Now, a good chunk of that, unfortunately, is due to our second law of thermodynamics. When naturally you do an energy conversion, some of that energy is going to be converted into lower quality, more dispersed forms of energy like heat. But then again, 43% of that energy is just wasted unnecessarily. Reducing energy waste could actually save the world about $1.9 million per minute. Most energy analysts say that reducing energy waste would be the quickest, cleanest, and the cheapest way to provide more energy, reduce pollution and environmental degradation, slow global warming, and increase both economic and national security. So what we could do is simply evaluate our energy resources for their efficiency to figure out how much environmental impact comes from obtaining that energy resource and how much useful energy that it provides. We can do that by determining the net energy that would be coming from that energy source to provide that particular task. Net energy is the amount of high quality, usable energy that would be available for a resource after subtracting the energy needed to make it available. For example, if we wanted to heat a home using electricity and resistive electric, and we started using uranium, fissionable uranium, well, after we subtract the wasted energy that came from mining the uranium, transporting it and processing it, taking it to the power plant and releasing the energy, transmitting over the electrical lines, the amount of available net energy left over to heat that home would be 14%. Whereas if we were heating that same home using passive solar windows, our sunlight, after transmission, we would have 90% of the energy available for that process. And so our passive solar is much more energy efficient than electricity from a nuclear power plant. Here's just one example of, in terms of heating and our net energy ratios. The higher the net energy ratio, the greater the energy available. So for heating, things like passive solar, natural gas, and coal are pretty reasonable energy sources in terms of efficiency for heating. So why are we still wasting so much energy? Well, part of it is due to the fact that we have lower priced energy sources like fossil fuels. Even with today's market prices, they're still relatively lower cost than many other parts of the world. And so there's very little incentive to save energy. Additionally, we haven't had a lot of government incentives or tax breaks. Now, in the past, recent past, we've seen things like cash for clunkers and some tax breaks for Energy Star appliances, but they've been few and far between. And then lastly, I don't think enough people understand what it means to be energy efficient and how much that efficiency can actually save not only energy, but also money. So there are a lot of different strategies we can do to save energy. One place we can start to focus is on our industries. Industry accounts for about 42% of U.S. energy consumption. Industry can save energy and money by doing things like cogeneration. For example, generating heat and electricity from a single source. If you're already combusting a fossil fuel to heat up water, to turn turbines to create electricity, well, why not then take some of that heated water instead of just releasing it as waste and use it as your heat source for your facility? Industry can use more efficient electric motors and find ways to have more efficient lighting, like using natural lighting as well as more cost-effective, energy-efficient LEDs and compact fluorescent light bulbs. We can save a lot of energy in our transportation market by increasing our fuel efficiency. On December 9th, 2007, President George Bush signed the Energy Independence and Security Act. And this act set the goal for the national fuel economy standards to 35 miles per gallon by 2020, increasing the fuel economy standards by 40%. And that was the first major fuel standard that had been set above the corporate average fuel economy standards, the CAFE standards, since that was created in 1975. And then with our recent president, President Obama, we now have increased those CAFE standards to be 54 miles per gallon by 2025. So if we kind of look at our average fuel economy in the 80s, when the CAFE standards were put into place to be able to increase those fuel efficiencies, they kind of plateaued and then in the mid 80s and hasn't really improved until more recently. So one way that these car companies will be able to meet those CAFE standards is by making vehicles from lighter and stronger materials. The automotive X Prize that was put together by Progressive was a major push for that, to see if people could push the envelope to create a car that could get 100 miles per gallon just using regular fuels. And a Charlottesville-based company actually won that X Prize, and their car got 102.5 miles per gallon. I was just reading in the newspaper the other day, and there's actually a Volkswagen that's hybrid electric with a small gas engine that can actually get up to 300 miles per gallon, available in Europe. So hybrid gasoline cars and plug-in electric cars make more efficient use of their energy inputs. The most efficient is getting up to 1,000 miles per gallon if used for short trips, up to about 40 miles. Currently, though, the big issue is that plug-ins would actually get their energy from places like coal and nuclear, which actually make them a little bit less sustainable. So if I have an plug-in electric in California, it's more sustainable because the electricity is coming from renewable resources, whereas if I am here in a southwest part of Virginia, where coal is the energy source for electricity, then my plug-in electric is still putting an impact on the environment in terms of fossil fuels. We can also save a lot of energy at home. We can save energy in building by getting our heat from the sun, using passive solar to actually be able to heat and cool our homes. We can save energy by super insulating them, using both man-made and natural insulative materials. Here we've got a home that's being insulated primarily by straw, which is a very high RF value, which allows for it to hold in a lot of heat. You can using plant-covered green roofs or building your home into the earth and using that as an insulator. We can save energy at home by using on-demand water heaters. Normally, a lot of folks have a freestanding water heater, and that needs to keep that water hot 24 hours a day, 365. If you've ever taken a hot tea or hot coffee and just sit it down for a while, eventually it's going to cool off. Well, these freestanding water heaters, the water that's inside is going to radiate off heat, and eventually it will cool down unless the elements on the inside keep it hot constantly, waiting for the need for that hot water. On-demand water heaters are going to heat the water only when you ask for it. And so that's going to actually save overall on electricity. In terms of heating and cooling our homes, we can use a geothermal heat pump. Just below the surface of the earth, we have a constant temperature. So on a hot day, the earth is about 60 degrees. So if you're able then to circulate water down into that portion of the earth, it's going to exchange heat with the earth and bring back cool water, which we can then circulate in our heat pump to help then blow air over that water and create air conditioning using the coolness from the earth. Similarly, in the wintertime, that earth is still going to be that same temperature. And so by taking the cold water that it would be in your heat pump and bringing it down into the earth and bringing up the more warmer water and blowing air over it, then that could be used to actually warm your home. Another way that we can save energy is by plugging leaks and using energy efficient heating and cooling systems, using energy efficient appliances and lighting. Things that have that Energy Star label have a certain amount of energy savings that are kind of built into them. One way to encourage and highlight the need for energy efficiency is Earth Hour, which usually takes place in March. Here, governments and homes all over the world will turn off all of their non-essential electricity for 1 hour. Places that are really famous like the Eiffel Tower or in Sydney, the Opera House, go completely dark for 1 hour, and kind of a testament to our desire to have a more energy efficient future. While this is only an hour, it really doesn't impact the amount of energy used across the world. It is a statement that governments and individuals are committed to having a more energy efficient world, such that we have the ability to be more sustainable and use less of those non-renewable resources into our future.